Is one solution. It covers properties of functions, sketching of a function, and trigonometric, logarithmic, and exponential functions. The next question is as follows. Given two corners of a triangle, the first is P with x value cosine theta, y value sine theta, and the second point Q with x value -1, y value 0. Question is, find the value of theta and the radius or hypotenuse. Here is a sketch of the x-axis and the y-axis, and here is the point Q of -1, 0, and there is the point P of cosine theta, sine theta. That is, the x value for the point P is cosine theta, which measures from the origin to the point where we have this perpendicular line. So this is cosine theta, which is this one, and sine theta is the vertical line which is projected from the point P and it's perpendicular to the x-axis. Here is the angle theta, so we call this angle theta. So we can justify now that cosine theta is the adjacent, which is cosine theta divided by the hypo, and sine theta is the opposite divided by the hypo. So that justifies calling them cosine theta and sine theta. Now, the 2 points P and Q lead us to the following conclusions. Number one, the line connecting P and Q equals to 1. That this line is equal to 1. The reason being the following. The square root of sine square theta plus cosine square theta equals to 1. Sure enough, the length of the hypo is equal to the adjacent square plus the opposite square, and then we take the square of the sum, the square root of the sum, and that will give us 1, which is right there. The angle at the point Q is theta. This is the point Q and this is the angle. The side adjacent to theta equals to cosine theta. So this is theta, its adjacent is cosine theta also. The vertical line connecting P and the x-axis has a length of sine theta. This is the vertical line connecting P with the x-axis, and it's vertical and it's perpendicular to the x-axis. So it actually divides the radius into 2 halves, and each half is equal to cosine theta. The vertical line splits radius into equal halves. Each half is equal to cosine theta. The value of cosine theta is equal to -half. And sure enough, the value is -half from this point to this point, -half. And this must also be equal to -half because this point is -1 for the x value. Thus, the radius is equal to 1 because we just justified that since cosine theta is equal to half, then this is 2 cosine theta, and that's equal to 1. But then when we're looking at the length is 1, but actually the value on the x-axis will be -1 because we're moving to the left of the origin. So now that we determined the value of this side of the larger triangle, and we know this side is also equal to 1, so and this side is equal to 1, and if we use this as a mirror, then we can see that this must also be equal to 1 because this is also a radius, and this is the radius. So this is equal to 1, this is equal to 1, this is equal to 1. 3 sides, this is equilateral triangle, so for that reason theta must be equal to 60 or pi divided by 3, and the same thing for this angle should also be pi divided by 3, and this angle pi divided by 3. So the answer to the question is that the radius is equal to 1 and the angle theta must be equal to pi divided by 3. For the next question, we have to determine the value of log to the base 1/3 of the number 81 without using a calculator. So we'll proceed as follows. Log to the base 1/3 of 81 equals to, we rewrite 81 as 3 to the power 4, and then we can just take the 4 to the left of log, so it will be 4 log to the base 1/3 of the number 3. Now we will take the reciprocal of the number 3, so that will be 4 log to the base 1/3 of 1/3. Because we took the reciprocal, then we have to raise this to the power -1. So this will be 1/3 raised to the power -1. Now we can also take -1 to the left multiplied by log. So it will be -4 log to the base 1/3 of 1/3. And that will give us, the answer is going to be -4. Look at the first question. The first question states, if the adjacent and the opposite sides of angle A of a triangle are equal, then pi/2 minus A equals to, we have to figure out this. Now, the angle A has the opposite and adjacent equal. If the opposite and adjacent are equal, and we're looking for sine and cosine in a triangle, that means one of the angles must be 90 degrees. If that angle is 90 degrees, then the hypo will not be one of the two sides that are equal, because it cannot equal to one side, because the hypo equals to the square root of the squares of the other two sides. So in that case, these two sides must not be, any of them must not be the hypo. That means for the angle A, one of them will be the opposite and the other one will be the adjacent. Having stated so, we know that the third angle is 90 degrees, and since the two sides of this angle A are equal, then the angles should also be equal. If the angles are equal, then the angles each must be equal to pi/4. Let's go ahead and look at the solution to the problem. Here is our logic. Since the adjacent and the opposite for angle A are equal, it follows that A equals to pi/4, and from that we can just figure out pi/2 minus A, which we just said it's going to be equal to pi/4. So the answer will be equal to pi/4. We have to plug in it right there. Let's take a look at the next question. Next question states that the point P, which has an x-coordinate -4 and a y-coordinate equal to 4, is the dimension of an angle in a triangle. Then the cosine of the angle equals. One more time. This point is at one of the corners of a triangle, and the point has -3 as it is x-coordinate and +4 as it is y-coordinate. If that is the case, then we want to look at cosine of that angle, and the answer is one of these four options. So let's take a look at the solution. Since the dimensions of P are -3 and +4, the opposite and adjacent are -3 and +4 respectively. It therefore follows that the cosine of the angle is 4/5, which is the adjacent divided by the hypo. That is the case, then the answer will be 4/5. Let's justify this by looking at a figure. Here is a circle. This is the x-axis, this is the y-axis, this is the point P. Since anything to the right of the y-axis is positive for x, anything to the left of y-axis is negative, so this point is -3. This point has x equal to -3, y equal to 0. This point has x equal to -3 and y equal to 4. We want the cosine of this angle, so no question that the opposite is -3 and the adjacent is +4. Since the adjacent is +4 and the opposite is -3, the hypo must be equal to 5. So the cosine of this angle is the adjacent, which is 4, divided by the hypo, which is 5. And that's the answer, 4/5, which is right here. Next question. The next question is as follows. Ln of 8 divided by ln of 2 equals 2, and we have 4 choices. Let's take a look at the solution. Ln 8 over ln 2 equals 2. We could change 8 to 2 to the power 3. Since we can say ln 2 to the power 3, then we can take the 3 to the left of the ln. It will be 3 ln 2. One more time. Ln 8 equal to 3 ln 2. And we are dividing by ln 2, so this ratio we can cancel ln 2, and that's going to give us the answer as 3. So the correct answer is D. So D is going to go right there, which is the number 3. Let's take a look at the next question. The next question is as follows. Let sine A be equal to 0.8. Then sine 2A equals 2, and we have 4 options to pick from. Let's take a look at the solution. Since sine A equals to 0.8 implies the opposite to A is 4 and the hypo is 5. It follows that the adjacent is 3. Thus, cosine A equals to 3/5. Therefore, sine 2A equals to 2 sine A multiplied by cosine A equals to 2. We know that sine A is 4/5 and cosine A is 3/5, as we concluded right there. So if we do the math, that's going to give us 24 divided by 25, which is option D, which is going to go right there. The next question is as follows. For how many cases the function y equal to a to the power x decreases? Let's take a look at the solution. When a is greater than 0 and less than 1, we're going to get a greater than 0 and less than 1. So whenever we raise it to a point, and that point is an integer that is positive, because we're looking at the increasing of x and its impact on a to the power x. If x increases and the base is a fraction, then the function will decrease. The second case where the function decreases is when a is negative value. That means the base is negative value. and x is an odd number. That's the second case, and you can go ahead and verify that. So we have two cases, and the answer is B. This is the answer, 2. Let's look at the next question. The next question is as follows. If 16 to the power c equals to 8, then the value of c is equal to, and we have 4 options. Let's take a look at the solution. 16 to the power c equals to 2 to the power 4 times c, and 8 is equal to 2 to the power 3. Since the base is the same, then the exponents must be equal. That means 4c must be equal to 3. It follows that 4c equal to 3 implies c equal to 3 over 4, which is equal to 0.75. So the answer is going to be over here 0.75. The next question is to sketch a function, and this not just any function. Sketch the function f of x equal to log to the base 0.5 of x. To sketch a function, we normally build a table and then sketch the function. But building a table for this one is a little bit complicated. So since sketching such function is not easy, let's consider its inverse. Let's take a look at its inverse. How do I get the inverse? The function f of x can be rewritten as y equal to ln to the base 0.5 of x. Therefore, its inverse can be determined by solving the equation that we get by replacing for y x and replacing for x y. So we have to solve for y to get the equation of the inverse. If we do so, we're going to get the inverse something like this: 0.5 to the power x equal to y. So this is the inverse. Let's call the inverse y equal to g of x. And now let's work for g of x. First of all, we can build a table for this one quite easily, because all we have to do is we have to choose different values of x. For ascending values of x, y should be descending. And for that, let's go ahead and take a look at the table for this function. And the table is as follows. We can see this is 0.5. If we raise it to the power -3, it's going to give us 8. We raise it to the power -2, it's going to give us 4, and so on. So this is the table for this function, and this function is the inverse of the function that we want to plot. So all we have to do is we have to just exchange the roles of x and y, and that will give us the table for log to the base 5 of x. So first, let's take a look at the plotting or the sketching of this function. If we sketch this function, we're going to get something like this. Okay, and since this is exponential function, this is exponential function, this one is exponential function, all exponential functions pass or cross the y-axis at the point y equal to 1, and this is crossing at the point y equal to 1. And of course, now we could go ahead and use this table by putting y instead of x and x instead of y, and that will give us the table for the inverse. So log to the base 0.5 of x, its table is right here. It's not easy for us to figure out the log when the base is like 0.5. So we got it in an easy way by looking at its inverse. So if this is the table for this function, then we could just go ahead and look at the graph. This is the graph for the function. This is the one that we're looking forward to sketch, and that will solve our problem in a much better way than trying to figure out this table from this function. That's it for this one. Let's go to the last problem. The last question we have to sketch the function which is x squared minus 4x plus 5. Sketching this as a polynomial, we're going to have to do a table, and calculating the table is going to be painful. It's complex, it's complicated. There are a lot of intricacies. What we can do is we can just break down this equation, and I'm going to show the breakdown of the equation using the sketches of graphs that we know, and then we will get back to the explanations. So let's go to the graphs. Here is a graph. Everybody knows that this graph is for y equal to x squared, because when x equal to 1, y is equal to 1. When x equal to 2, y is equal to 4. When x is equal to negative 1, y is equal to positive 1. When x is equal to negative 2, y is equal to positive 4. So this is the sketch of y equal to x squared. Let's take a look at the second sketch. The second sketch is for y equal to x squared, but we went ahead and displaced this one. That means we moved it 2 blocks. So we moved everything 2 blocks. That means the origin is no longer is the least point. This is the point with the least value of y equals 0. So y equals 0 becomes at the point x equal to 2. So this is equivalent to saying this is y equal to x squared, and this is y equal to x minus 2 all square. This one. So this one represents y equal to x minus 2 all square. Let's go ahead and do the second move. The second move is to shift this one up by 1. And if we shift it up by 1, we achieve this equation. This equation is achieved. Let's go ahead and label each and every one of these curves. We know that the label for this one is y equal to x squared. If we want to shift this one to 2 blocks, we have to subtract 2 from x and then square. So this is the function. 2 subtracted from x, and we square the result. That will give us this function. And then we can see that this is equivalent to this one, except we have to add 1. If we add 1, that means we want to shift this one up by 1. If we shift this function up by 1, we get this function. And this function is basically f of x equal to x squared minus 2 all squared plus 1, which is equal to this one, which is the sketching of this function. So it's just that we have to, anytime we have any polynomial, we have to see if we can break it down to functions that we know, or at least one function that we know, and then we could go ahead with shifting up, shifting down, stretching the function, shrinking the function until we get our answer. That's it. And thank you for watching, and you have a great day. The next question is about evaluating cosine for theta, where cosine theta equals to square root of 3 divided by 2. To start with, we're going to expand cosine for theta. It's going to be equal to cosine square of 2 theta minus sine square of 2 theta. We're going to have to find the identity of sine square 2 theta, and that is 1 minus cosine square 2 theta. Now we can see that we can add these values together, and that's what we're going to get. 2 cosine square 2 theta minus 1. And now we have cosine square of 2 theta. We can also rewrite this one as 2 terms. So that will be 2 cosine of 2 theta multiplied by cosine of 2 theta minus 1. Now we will go ahead and also use the halving of the angle. So we could replace this by 2 cosine square theta minus 1, and also the same thing for this value will also be 2 cosine square theta minus 1, and then minus 1, which is this one. All what we did is we used the halving rule. So cosine 2 theta is equal to twice cosine square theta minus 1. And of course, when we do the math, we're gonna get 2 multiplied by 4 cosine to the power 4 theta minus 4 cosine square theta plus 1 minus 1. Now we can go ahead and use the value of cosine theta. So we have cosine to the power 4 theta is just square root of 3 divided by 2 to the power 4. And if we do the math, that we will have what, 4 on this side, and instead of cosine to the power 4 of theta, we're going to have 9 divided by 16, which is just raising this value to the power 4. Will give us 9 divided by 16. Minus 4, now cosine square. So we have to raise this value by the exponent of 2. So that's what we're going to get. The square root of 3 square is going to give us 3. The square root of 2 is going to give us 4. So we have 4 multiplied by 3 divided by 4. And then plus the inside 1 and then the outside 1. If we do the math, we will find that this is going to lead us to 9 divided by 2 minus 6 plus 2 minus 1. And this will eventually give us the answer to be negative half. And that is the answer for this problem. And that's the end of this questions and answers. Good luck.